I want to pick up where we left off on Friday and continue talking about when we would use a sample versus when we would use a census. So I mentioned that if we had things like destructive testing, or if we had a huge population, there might be a reason one way or the other. On page 32, we see these tables. A census is if we have a small population or a large sample size that would basically be a very big fraction of the population. If there are legal requirements, if there's an easy database. On the other hand, samples, as I said, destructive testing. How accurate do I need to be? How much is it going to cost me? This is a very, very specific reason that comes up a lot. I could ask every single person. Chasing them all down isn't always easy. Keep those in mind when we decide whether we're going to do a sample or a census for our gathering. Now, I have decided on a question. I am going to go collect information. I'm going to get some information from my question. Let's assume I have a population, everybody, everything I'm interested in, of size capital N. And I take a sample of that group, and the size of the sample is little n. So whenever I use n, I mean the size of something, but it's going to depend on whether it's capital or little as to whether I'm talking about the whole population or just my sample. From my sample, I can calculate, remember, based on my measurement levels, what type of calculations I can use. I can spell too. Calculate a statistic. Maybe that's the average. Maybe that's the maximum. Maybe it's the minimum. Maybe it's the range. Maybe it's the variability. There are all sorts of things I'm going to do. But that statistic is used to estimate a parameter of the population. So parameters are things that apply to the whole population. A statistic comes from my sample. Now, the goal is to get good estimators. And usually we're going to use symbols for these. So my population may have an average. It may have a variation. It may have some proportion. How many people prefer candidate A over candidate B? Please notice that these are all Greek letters. When we're talking about our population, we almost always use Greek letters. On the other hand, in my statistic, when I calculate those same things, I use usually a Roman letter, maybe modified with some sort of symbol indicator like X bar for an average, S for a standard deviation, and little p for a proportion. So I go out and I survey 100 students. Do you like the cafeteria food? Yes or no? That's a proportion from a sample, and it's used to estimate the proportion in my population. Frequently, this is the one that bothers me the most because I see pi and my brain goes 3.14159. That's not what pi means in this course. It is normally what pi means, but it isn't what pi means here. So the population contains parameters. The sample contains statistics. Statistics estimate parameters. Normally, I would say questions, but you're not here for me to actually ask questions to. So if you have a question, pause, email me, or come to my office hours this afternoon. Even though we're not on campus, I'll have office hours virtually. Okay. When I ask a question, I have a target population in mind. So if I'm asking about the cafeteria food, it doesn't make sense for me to ask people who are fully remote students. It doesn't make sense for me to ask students enrolled in the college and high school program who are technically on the Seton Hill rolls, but they're at high schools. They're not on this campus. So if I'm asking about the dining hall, they're not part of my target population. I then need to create a sampling frame. The sampling frame is the group from where I will get the sample. Ideally, this should match the target population as closely as possible. In terms of distribution of demographics, so demographics, the qualities of the group. I want to know, do I have the same amount of women and men? Do I have the same number of athletes and non-athletes? Do I have the same number of resident students and non-resident students as the population does? So I get what is called a reflective sample, something that reflects my target population, a representative sample. Now, how do we do this? Well, I've got a bunch of information about students. If I want to ask questions about the dining hall, I might be able to send out an email survey. I have all your email addresses. If I have a phone list, if I'm asking about votes, I could ask, hey, where's the voter registration list? So I can look at all the people who are registered to vote in this neighborhood, and I can decide what the right number of people to ask is. Maybe I should look at customer databases. Did you sign up for a membership card at my discount store? Well, then I have some information and I can use that to get at you. So if I have a good way to get my target population's information, that's going to save me some choices. So let's think about what we should do based on the kind of question we're looking at. Here, question 15. If I wanted to measure the model years of the cars driven by your 5 closest friends, would I do a sample or a census? I'm only asking 5 people. I think I can ask them all. The model years of the cars driven by every student in your stats class. Look around. If everybody's here today, there are less than 20 of us. You could ask everybody. But if I asked for the model years of the cars driven by each student in your university, would I do a census or a sample there? Seton Hill's pretty small. I might be able to do a census. But there are, I don't know, 1,500 students here. Is it worth it to track them all down? Maybe I'd be better off doing a sample. If I was at the University of Florida, where I got my undergraduate degree, there were 40,000 students at the University of Florida. If I were at Pitt, there are tens of thousands of students there. If I was at Penn State, no, I'm not going to do a census there. I'm going to do a sample. So we can choose based on the size of our population how worthwhile it is to try and ask all of them. Excuse me. Down here, I want to know if the thing I am asking reflects something about the population or about a sample. So in 17A, the average price earnings for the entire set of 500 stocks on the Standard & Poor index. Well, wait a minute. The target population is all stocks in the Standard & Poor index. So this says the average price earnings ratio for all of them. That's a parameter. It's about all of them. The proportion of all stocks that had negative earnings last year. Again, I see all stocks. That's a parameter. The proportion of energy-related stocks in a random sample of 50 stocks. I'm only looking at 10% of the population. I'm not looking at the whole thing. This is a statistic. Now, I could ask, what is the proportion of energy-related stocks in the entire S&P 500? That would be a parameter. And this statistic that I calculate here in Part C could be used to estimate that parameter. With only 500 stocks to look at, I might be better off actually doing a census and looking at the proportion of all stocks that are energy related rather than just a sample thereof. So, again, at this point, I would ask if there were questions. How do I get samples? There are two main types of sampling methods: random and non-random. Let's start with random ideas. Again, my population size is capital N. My sample size is little n. A simple random sample is one in which every member of the population has an equal chance of being selected. The easiest way to pick them is to assign a number to each one and use a random number generator. If you give me a second, I will go get my favorite random number generator. I said we had 20 students in this class, right? Well, if I have 20 students, I can generate a number between 1 and 20. Person number 15. Person number, oh, wait a minute. If you look carefully, you'll see there's a little dot in the corner here. That makes that a 9. See how this one has a dot? That makes that one a 6. You have to be able to tell them apart. The more people you have, the more sides you need on your dice. Sometimes, you have fewer people. Maybe I only have 4 people. If I have 4 people, either I need a die with 4 sides. When you roll this one, the number you're looking for is the number that's upright when it's laying down. Or maybe I roll a regular die and I say, oh, I rolled a 3. I rolled a 2, that's a person. I rolled a 6, I need to roll it again because I don't have a person number 6. So we have all sorts of random number generators. You can generate numbers randomly using a computer. One of the first randomization methods was created by the Rand Corporation, and they actually physically put out a number booklet. And you could open it up, point to any number, and start going down in the table of numbers on this page. You just start going down the page, and it would give you a randomized list of numbers. We can do this in Excel. There is a very nice command in Excel. Let me show you my Excel screen. Share Excel. Here we go. If I want to generate a random number, I can write equals RAND. You see things start showing up? If I click on one of those, rand between, then I can give it a range. I wanted a number between 1 and 20. Boop. As a matter of fact, if I drag this and make copies, it'll generate random numbers. Hey, wait a minute. I see something really interesting. Each of these randomly generated numbers is completely uncaring of what happened in the other boxes. I generated 10 random numbers between 1 and 20. The number 20 shows up twice. The number 18 shows up twice. The number 5 shows up twice. Now that is actually important because we need to think about the idea of using our random number generator and either sampling with or without replacement. With replacement means once I pick the number, I put it back in the pile and it could be picked again. Um, when I attend a conference in March, there is a student problem competition. So we hand out 9 problems and students work on them in groups and we have an hour. And at the end of the hour, when you get a problem and you get it right, you write your name on a little color-coded piece of paper with the problem number on it. And we take all the solutions for problem number one and put them in a box, and two and three and four, all the way up through problem nine. And then we reach into the problems that were solved by the fewest number of people, and we draw a name, and we give them a prize. But if you solved the problem five and problem six and problem eight and problem two, you could be chosen more than once. The other version is without replacement. Sampling without replacement is what most of us think of. And that means, like, pick a card from a deck of cards. Well, then, if I tell you to pick one card, you take the card, you put it in your pocket, you look at it, maybe you put it back in the deck. If I then tell you to pick a second card, you could pick the same card twice. But if we're playing poker and I give you two cards, you shouldn't be able to get two of the same card, or the deck is a problem. Our Excel function allows for replacement. It allows for repetition. So we need to be careful if we really want to make sure we have distinct items in our list. We need to be careful in how we choose them. And that may mean going back through our Excel list and saying, oh, I need to know how many of these are different. And I need to make sure I get 10 actual different numbers. Well, right now I have 11. That's one. 25, one. I got four, five different numbers, six different numbers. Wait a minute, I've seen that one before. So I only have six different numbers. Seen that one before. I only have six different numbers. Seen that one before. I only have six different numbers. Six different numbers. I need to keep going until I get more different numbers. Ah, there's a different number. One, two. See, when I hit enter, they redid themselves. I hit enter and it reevaluated. So let's count again. One, two, still two, three, four, five, six, seven, eight, nine, 10. I now have 10 different numbers. See, we have to be careful about how many numbers we actually need for our sample to make sure we have distinct individuals. If the number of people in my sample is close to the number of people in my population, then sampling without replacement is biased. If you're not chosen at the beginning, then there are fewer people in the group when they choose later, right? If we had 100 people and we needed to pick 50 of them, well, when I'm in the very beginning, my chance of being chosen is 1 in 100. But then my chance is 1 in 99, and then my chance is 1 in 98, and then my chance gets bigger as I sample without replacement. And that biases our result. It gives the people who are later in the list, or uh, who are chosen from the later group, a larger chance than people at the beginning. So it technically isn't random the same way. We've changed things. This close to isn't very mathematically precise. So we'll nail down what it means, but really I want to think of the ratio between n and n. Really, if the amount of people I am picking from is much, much bigger than the size of the thing I want to keep, I'm not going to worry about this. We'll talk about this a little bit more in chapter 8. If this ratio is small, let's say 5%. So I'm only trying to pick one out of every 20 people. We're going to call that, I can spell, effectively infinite. It really isn't infinite, but it's effectively infinite. There are 20 other people who have a chance of being chosen. Sorry, 19 other people for every person who has a chance of being chosen. This is 1 out of 20. That's a really small chance. Um, Effectively infinite populations are where I can use my random number generators. As a mathematical aside, if you really want to investigate the idea of being random, many programs, like our Excel program, are really not truly random. There's something called a pseudo-random number generating algorithm, because true randomness is really rather hard. There are lots of ways to do randomness. One of my favorites, hang on a second, I need to Google something really quickly. Um, Cloudflare. Cloudflare is the people who do CAPTCHAs, the things, are you a human being when you log into a website? Do you know how Cloudflare does its random number generating? They have a wall of lava lamps. I wish I was making this up. Cloudflare has its wall of lava lamps, and they have a camera pointing at these to generate random numbers. True randomness is very hard. One of my former colleagues worked for Konami Gaming. He built algorithms for slot machines. Because he built the algorithms, he is forbidden from using Konami slot machines. He's not allowed to go to the casino and gamble because he's seen behind the curtain and he can watch the pattern. He may not remember it, but he worked there quite some time ago. But he could, and therefore he's not allowed to use slot machines that were made by Konami Gaming. Okay, so simple random samples pick a number out of a hat. But I really need a big hat compared to how many things I am picking. Maybe that's not helpful. Maybe what I need is a systematic sample. I know I'm going to pick the every 10th person or every 100th person or every, I know, pick every kth item for some fixed value of k in our list. So remember, we assigned a number to each person in our random sample idea. And then I can pick every 10th, every 100th, every 1,000th. If I'm making pencils and I want to know quality control issues on my pencils, how many pencils do you think I make in a day? If I make 100,000 pencils in a day, I can't test them all, but I could test every 1,000th. That would give me 100 pencils to test. This is most effective in infinite or nearly infinite, effectively infinite populations. Or with populations that don't actually have a good way of listing them. Or if there's really linear organization. Remember, I was talking about my pencils. I could think of them as coming off a production line. If I'm making medicines, I might take, let's say I'm making aspirin. I might make it a policy that I'm going to select every 1,000th pill to come off the line to make sure it holds together, to make sure the coating is adhered properly, to make sure that it dissolves properly in liquids. I could do all of those things. Now, K should be roughly equal to the size of my population divided by the size of my sample. However, if there is any sort of periodic behavior, then I will have a bias show up. Let's, for example, pick spending patterns. When do you think people spend the most money at a bar? Monday night, Tuesday night, Wednesday night, Thursday night, Friday night, Saturday night, or Sunday night? Well, if I was doing a systematic sample and I said, I'm going to go to the bar every Friday, wouldn't that bias things as opposed to going on random days of the week or going on every day of the week for a particular week? Maybe I go on every day of the week for the week of spring break. Oops. I need to be careful when I decide I'm going to do a systematic sample that my system doesn't influence my choices. But if I'm going to do a system, maybe even then I need to think about the population a little more closely. stratified sampling. If my population has some sort of uniform subgroups, um, maybe I could think of different racial and ethnic groups. Maybe I can think of different gender and gender representation groups. Maybe I can think of different political groups. I might want to make sure that the strata, we're going to call these subgroups, the layers, then I can take a random sample within each layer. And that allows me to spread my sample across all of my groups. So suppose I had a population and it really had group one and group two, all the way up to group L, the layers, layer one, layer two, up to layer L. Then you take your sample in the same way. Ideally, I want the size of this sample to be the proportion in group one. I don't want to overestimate group one by taking almost all of my sample from group one and missing everybody in group twos, three, four, etc. I think this is useful. Now, this actually allows me to get a better representative sample because it allows me to say, well, I've got all the groups. If you've ever been filling out a survey and then they ask for your demographic data, what is your age, your race, your gender, and they ask all this, sometimes they ask your um, income. So they know, are we getting people who are middle class, upper class, who are rich beyond dreams of avarice? Who are we getting when we do this sample? That's useful information. So we should keep track of that. The other way to do this is to take one big sample and then weight it. Now that sounds a little more complicated, so let me give you an example. I want to study how many people are getting vaccinated for measles. Hey, there's a huge measles outbreak in South Carolina right now. As a matter of fact, it is possible that measles will be a disease that we are no longer herd immunized for in the next few years. And I look at my group and I say, in my group, in my city or in my state or in my county, whatever I'm looking at, my population is 55% male and 45% female. Yes, this survey only gave two choices for gender. I'll live with that. And I want a sample size of 200. Now, what I could do is I could say, okay, if I want a sample size of 200, then I should take the male group should be 55% times 200. That's 110 people. And the female group should be 0.45 times 200. And that's 90 people. So I start looking at my surveys as they come in and I ask people, hey, are you vaccinated against measles? Yes or no? Are you male or female? And as soon as I have 110 responses in the male group, every other response I get from somebody that's male, I throw out. As soon as I have 90 people in the female group, I stop taking answers. The other thing I could do is I could say, oh, what I could do is I can say, let's take a totally random sample and then we'll take the answer and we'll multiply by 0.55, A and S for answer, and that'll give us the male answer. And we'll take the same answer and we'll multiply by 0.45, and that'll give us the female answer. And that reflects the same proportion as what's going on in my group. This example is the bottom of page 37. Now, sometimes the strata that we choose is chosen based on geography. And in this case, the strata are geographical regions. What? Buildings. I want to ask something about the dorm. I should ask people in Farrell. I should ask people in Havey. I should ask people in Sauk. I should ask people in Deschanel. I should ask people in all of the different dorms, and I should make sure that I have some from each dorm based on the size of the dorm, right? I could also look at like school districts or counties or towns, parishes, churches, congregations, lots of things I can do. Now, this is really a two-stage pick or a one-stage pick. What I could do is I could say, all right, I am going to pick, I want to ask about the dorms. I'm going to pick a dorm. Now, that might mean that I'm going to ask questions about the dorms, but I'm only going to ask people in Havey, or I'm only going to ask people in Farrell. That might work, but maybe I could also do a two-stage or even a multiple stage. And first, I select some number of strata, subregions, and then sample within each one. If you look at the top of page 39, we could think about our school district idea. I want to ask about school districts in Greensburg or in Pennsylvania, and I have a whole bunch of different districts. And I roll the dice and I say I'm going to choose 3 districts, and then within each district, I'm going to pick 4 items. So here's District 1, 1, 2, 3, 4. Here's District 2 that got chosen, 4 items. Here's District 3 that got chosen. So this is a clustered sampling. I'm only looking in certain places. This lowers my costs because my samples are close together, and that means I don't have to travel as far. This is useful when population frame and strata characteristics are hard to obtain. So it's not easy to ask people about some of these questions. I want to make sure I have enough rich people and poor people and middle class people, and a lot of people don't like to talk about money like that, so you won't get good answers when you ask those questions. Or uh, costs increase a lot with distance. And it doesn't make sense for me to go and ask people in Allegheny County and then in Bucks County and then in Philadelphia and then in Harrisburg, and driving all over the place and flying all over the place is expensive. So what if I just did some sampling in Allegheny and had somebody else do some sampling in Bucks County? I could do that easier. And there's a trade-off in bias and reliability. If I asked about the quality of the housekeeping in a dorm, well, which dorm I'm in and which uh, group of Aramark employees do each dorm might matter. Um, Regional variances make this sort of ideal for similarities in neighborhoods. If you live in a particular neighborhood, you probably have things in common with the people in that neighborhood. So using that county or that school district as a basis for deciding on where I should do my sample makes sense. The Bureau of Labor and Statistics does a lot of multi-stage cluster sampling. Now, I have a couple of other samplings because these are all primarily randomized samplings. There are non-random samples and other types of samples we can do. We'll keep talking about this on Wednesday. I hope you have all had a safe, warm Monday. If you want to come talk to me and ask me questions, in spite of the fact that it is Monday and we are not on campus, you can go to our Canvas page. And here on our Canvas page, there is a web link. Down here in the links section, keep scrolling, web links. There is the Google Meet for office hours. If you click on that, it will open up Google Meet. Make sure you are logged into your Gmail account, and it will connect you to the meet that I will have on Monday at 1:50 to 3:30. I will be available via Google Meet during that time. The recordings are all on this playlist. Where's the link for the playlist? It was on that same web link section. YouTube playlist for all recordings of this course. And my written notes are down here at the bottom. I will see you all on Wednesday. Have a wonderful rest of your day.